Well, it's exciting. We are here live again. My name is Erica Hughberg, and I'm here with Skylar. And I am really excited because we will talk about what it actually takes to become an AI engineer, probably less than what people think. And we will be talking about how to take your AI features and applications from POC to something that is actually live and maybe what that journey can look like. So, well, who is Skylar? Why is Skylar here? So Skylar, where are you based in the world? I'm in the east coast of the US, so where are you in the world?
I live on the West Coast. In particular, I live in a place called Bakersfield, California. I grew up here, and now that a lot of work is remote, it's nice to be near family. So I'm enjoying that.
Yeah. I'm doing sort of opposite. I work remotely, but I'm very far away from family, so I'm remote away from family too. But so, by the way, if you're here listening live, but feel free to drop a comment, say hi, share where you are in the world. Love to get some live comments showing where people are from. So, hello. And well, Skylar, who are you and what have you done in your career? Obviously, I know a bit about that, but I think that it would be lovely if you can share a bit about that to anyone who's listening in.
Yeah. So I've been working on AI systems for over a decade now. So a lot of different types of problems, a lot of different scales of company, a lot of different industries. So I started my career at Google working on ad policy enforcement. So a lot of stuff to make sure that porn doesn't end up in your ads or things like that. And then I moved on to doing a lot of different things at LinkedIn, really focused on search and recommendation, particularly personalized search and recommendation. And so I think that's where I really cut my teeth in my career and kind of learned a lot of what I know. And it was a very formative experience at LinkedIn because we found that like a lot of times the tools and infrastructure we had for machine learning at the time just wasn't quite there. This was when MLOps was in its infancy.
Yeah.
And so people were still trying to figure out the playbooks. And so learned a lot through that era. And then moved on to startups and worked a lot in the mental health space. It's very near and dear to me. And so did a lot of work in that space. And for the past year, I had been consulting and just helping a lot of companies implement AI. Now that AI in some sense has been commoditized, everybody has access to it. It seems very easy to use and adopt, and there is so much value to generate, and everybody's clamoring to get it. And sometimes they just need a little extra help, and so I've been doing that. More recently, as I said before, I joined a company full time. I'll keep that under wraps for now. But, yeah.
And see, there was a few things you said that is quite interesting, but one thing you said was that AI has become commoditized. So does that mean it's easier to build quality, or does it just mean that it's easier to build something?
I think both in a sense, but more easier to build something. So, back when I started my career, if a product manager said like, hey, I have this idea for like a really cool feature, it's going to use machine learning, yada, yada. Most of the time the answer was like, okay, we're going to spend a quarter collecting data. And you kind of needed that before you had anything. And that's really not many people have a lot of appetite for that, because it's a pretty hard bet you have to make to spend a quarter collecting data to hopefully find out you could even do it.
Yeah.
So I think what the commoditization of AI through LLM APIs and just broadly generative AI model providers has given us is it's much easier to start with much less data. And so you can get a prototype out that kind of works and actually does something, useful. And I think that's getting started fast is very important, because like at the end of the day, I'm sure we'll get into this a little bit more, everything's about like starting this flywheel effect of finding where your system doesn't work and then, improving it from those defects. And over time, you should be building a system that is easier and easier to improve. And so the faster that you can get started and get into that loop, the get the flywheel spinning, and the faster you can get through like maturity cycles and get to actually truly great.
Yeah, we're definitely going to talk about that in more detail, because you have shown me some amazing things, like really, well, say amazing things. You literally took it and made it easy to understand what that process can look like. But before we get there, what actually made you interested in MLOps and AI? Like, what actually inspired you to? Was it necessity out of work? But what made you stay in that case?
Yeah, so it's a great question. And so like, I think we kind of have to like rewind back to my years in college, but I went to UC Irvine, and I took a machine learning course there just as part of an elective, and I didn't think much of it when I first started taking it. But after that course, I was so fascinated with machine learning. I really felt that it was just the coolest thing I'd ever seen. The idea that, you know, I didn't need to like sit there and type out the actual instructions and behavior to a computer so that it can do something. It can just like learn what the right thing to do is from data. And, you know, I just saw a lot of leverage in that idea. And so I actually stopped taking a lot of my required courses in college and took graduate machine learning courses instead. Which, you know, at some point made it a little tricky to actually graduate, but we pulled it off still.
You figured it out.
Yeah, we figured it out. Took a lot of begging the counselors, but we made it happen.
Yeah.
But yeah, I was just so fascinated by, I could tell that there was like an insane opportunity there that I really wanted to get into. And, you know, I think as far as like it pertains to like, you know, getting into like more of the ops or infra side, I think this was just a natural thing for my personality. I have never cared very deeply about the kind of work that I do. I try to just find like what's not getting done and let's go do that. And I think, you know, during the craze when a lot of like ML ops was starting to spin up and we're starting to learn those best practices, the reality is everybody wanted to work on the sexy modeling. And so you had, you know, dozens of people that were trying to do that and just wanted to fiddle with hyperparameters and change the model architecture. And pretty much nobody that like really wanted to do that grunt work, I guess you might call it. Like, hey, how do we get this to work seamlessly, easily, et cetera? And so just naturally, I found myself gravitating towards some of those things because that was the biggest problem. But I also like worked in teams then, whereas like, oh, we actually need somebody who focuses on like the more data sciencey aspect too. So I find that like I've just been very fluid in that sense, and have kind of like, you know, done very data engineering things, done very like infrastructure things,
that's really
very
cool.
like modeling things. But yeah,
I feel like that is also actually quite a rare combination that I don't come across that very often. The people who both have a data science and machine learning or AI perspective, but also have a good understanding of infrastructure. I think that has become more common over maybe the last year. But yeah, I totally don't feel like that is a common combination of interests.
Yeah, you know, and I don't think, I wouldn't call it interest. And, you know, to be like very fair, like I would not say that like I'm great at any of these things. I think, you know, I'm good enough at all of them to like get things done. And I'm not so bad that I'm going to make a mistake that's going to bankrupt the company, but I might make a you know, pretty dumb mistake because I'm definitely not an infrastructure expert. But I think I've always just valued like delivering value at the end of the day. And that often takes a lot of different skill sets. And I think, you know, a lot of the time, the reality is companies don't have priorities aligned very well. And so when you need somebody from infrastructure to do something, and also someone from data engineering to do something, and also someone from this team, getting all those separate teams to have their priorities aligned in a way where you can ship the thing you're supposed to, very difficult. I've found it much easier to just like, let me try to learn what I can to kind of like scoot it along.
Yeah, I think that's quite interesting. I've definitely seen that and been in that situation myself in work, where it feels like there's a bunch of forms you may have to fill out, especially if you're in a large company. Like there are forms and approval processes to even get the infrastructure anywhere that you'd actually want it to go. And definitely seen the need for people having to get their head around things and make stuff happen, because otherwise you're waiting for 2 weeks for someone to action a form you filled out that turned into a ticket that sits in a ticket queue somewhere in the infrastructure basement, or whatever we want to call it. It may get lost and forgotten as well. So that's really interesting. And I sort of want to talk about what it really takes to solve real user problems with AI-powered features. Do you think this is the time you want to show your flywheel, and then we can go into the details? I don't know when it's the most appropriate thing to show. Or I don't know if this is the flywheel, but this is the thing that really helped.
Maturity model,
help me understand. Because one of my questions to you when we chatted one-on-one was how, like, quality, like how did you do quality gates and maybe like evals and things like that? But then you showed me that you might not have to go all in on automated evals day 0 or 1 or whatever we want to call it.
Yeah. So this is, while I was consulting, this is like a common graphic that I used just to try to walk people through my process. But, I think that the reality is, like, the word evals, I hate the word now, because everybody seems to have a different, like, understanding of exactly or precisely what it means. And so, like, when you see people arguing about whether you need evals or don't need evals, I think the word itself is bad as a load bearing word, because like, somebody might say it and they might mean something fully automated. When you look at like Shreya Shankar and Hamal Hussain, who are kind of like the eval, I'm going to call them the eval king and queen, of AI land. They have like a pretty structured definition that includes a lot more than just that. They're really focused on, like, hey, eval is any systematic process you go through to evaluate the quality. And so I think that people just have like very different ideas of what it means. And so, the first thing I say is, like, throw that word out for a second. Let's just try to understand, what are we trying to do? Ultimately, at the end of the day, we have some value we think we can deliver to our users, our customers, and we think AI can be helpful with it. And as with anything, everything is this trade-off of, like, how can we as quickly as possible get to where we need to be? How do we make sure the maintenance and operational costs are kind of kept in line? How do we reduce risk? And so, like, these are all of the concerns, and whether you're building AI or not, the same high level concerns exist. But once you start, like, distilling down into, like, okay, what do I practically need to do to kind of, like, contain risk? With AI features, it starts to become a little bit different than traditional engineering. And the key reason is that these systems are highly data dependent in a way that traditional software is not. So when we think about traditional software, it's dependent on data, usually in sort of a shape or size kind of way. So if you have data that is a certain schema, if you go and change that schema, something might break. If you build a certain system and you suddenly, like, 10x the load, it might fall over and break because the architecture can't handle that. But very rarely do you have systems where it's highly dependent on the actual content of the data. You might have general heuristics or rules looking at the content, but it's not like if you added an extra space somewhere, everything's going to just break apart for the most part. And that is something that can happen with these LLM technologies. And that's something that a lot of people have run into, that exact thing of, like, oh, my system stopped working and I couldn't figure it out for a while. And then I found out there was an extra space here. And so,
that's mental.
That level of, like, data dependence means, like, hey, maybe we need some more approaches and techniques to kind of, like, manage these systems. And so,
and by the way, I really liked what you said there about thinking about when we have traditional software engineering and we do testing, like we do load testing, we do data schema testing. that is in a way testing all the scaffolding around the content, versus in this generative LLM AI world, we need to actually somehow quality check or test that the content, the data itself doesn't mess up. Am I understanding that correctly?
Yeah, exactly. And so what that really gets you to is, at the end of the day, if I have an example, like let's say that we're building a system that uses an LLM to evaluate a resume for a job.
Yeah.
And let's say you're a hiring manager and you have this job posting,
Yeah.
and you have a list of candidates. And let's say we run it and you look at the results and you're like, wow, this is great. This is exactly what I want.
Yeah.
Does this system work? I don't know. It works for you for that job, for that set of candiits. Does it work
very
for
narrow.
yet another set of candidates, right?
Yeah.
And so because of that data dependence, we start to have to, it's not the case so much. So like with traditional software, if you had some sort of system that had, let's say like you had a data element that had a name. If you change the name from Bob to Nancy, you generally would expect it to not change. And honestly, if you had two tests you wrote in a PR and one tested with Bob and you had a separate one testing for Nancy, I might look at it and say like, do we need both? You know?
Yeah.
Like,
because the functionality is the same.
Exactly. And so that's where kind of like there's a sharp difference in working with LLM systems. And so this is the point. That's a point that I think a lot of people intuitively understand, even if they maybe haven't quite said it out loud yet. But I think what that tends to do is push people too quickly into, we need to build a data set. We need to like cover all of our inputs.
Because I do hear people saying, oh, we need to have good data before we even can think about building an AI feature. We need to get all of this data before we can think about, maybe this is related to that, why people say that.
Yeah. And I think it is. And that's a very common thing for people to say. And I think it's often said by people who don't understand business needs deeply, and they're thinking only about the technical needs. And so there's a trade-off here that is kind of implicit in this diagram, which is, if you want to have high confidence that your system works, you need to have basically a whole catalog of, here's all of the different possible things we might see. Here's all the inputs we think we might see. And you need to like assess the performance over all of those. But on day zero, do you have that? Probably not.
Yeah.
Very early on in a product, like any product you build is an act of discovery. You don't know from day one exactly what users you're going to serve. You have a hypothesis. You're like, I think these are the people. And that hypothesis is probably neither precise nor accurate. Meaning it's probably it's not that it's totally wrong. It probably has it. The reality is human intuition has some value. And so it probably has some good things in it. But there's probably some qualifications you have in your ideal customer profile that aren't quite right. You probably are missing some. And probably there's like entire groups of people that are going to fit in nicely and you just haven't found them yet. And so like that's something that's naturally going to evolve over time as your understanding of the product, your users, et cetera, changes. And
does that come into like trying to collect like actually usage analytics and how people are actually using your solution then to understand what's going on?
Totally. And that's product analytics is big space for that reason to understand that, so you understand where to make bets. And so the reality is, like, when we're building like AI things, there's a similar thing that happens on day zero. You don't really know who the users are. You have a guess. And so if you spend all of your time trying to build this sophisticated data set that captures all of your inputs, that you might possibly want to do good on, that's probably a lot of time, a lot of investment for something that is maybe likely to change. And so, you have a similar thing with testing a system. If you're building a prototype of something because you just want to, you want to do some kind of spike just to see, hey, does this approach work? The reality is you probably are not going to write a lot of tests there because you don't need the ongoing maintenance of it. The tests are probably something that slow you down more because you're probably going to change things a lot. And those
Become
tests
test
are likely to break.
maintenance.
Exactly. And so there's a similar thing with evals where you can have like this eval debt or eval maintenance because you tried to build this very sophisticated thing too early on when your understanding was at its minimum.
Yeah.
And so that's why I like to use this maturity model where, hey, at stage one, let's not focus on all that stuff. Really, there's a lot of low hanging fruit. Let's just focus on making iterations really fast. So make it so we can run the thing, whatever that means. Make it so we can see what happened, whatever that means for your problem.
Yeah.
And then make it so we can make a change and then see the new version,
Yeah.
Make that as fast as possible.
And so we do have a question from Faisal here. So Skylar, in practice, do teams move linearly through phases or bounce between them? And I'll add my question on that. Have you seen people bounce backwards in these phases?
Yeah. So one thing I'll say is like to some degree, these are almost they're not completely dependent phases. And so there's like some level of independence in these as being capabilities you could build. So for instance, you could technically build things that do some form of automated improvement, even before you really have a data set.
Yeah.
And so this is just a graphic, the adage, all models are wrong, some are useful, definitely applies here. This is a way to kind of like summarize what I think is a helpful process to go through, rather than, thinking very strictly about it. But yeah, I definitely do see teams bounce between them. Typically what I see happen is teams will often jump to either I see a lot of people jumping to phase 3, honestly.
Okay.
So people see that LLM as a judge is a thing, and people jump straight into doing that. And the reality is, you should be very suspicious about using AI to evaluate your AI. Because if you're suspicious that your AI might not work, why do you think another AI is going to like work in telling you that it doesn't work? And so all of the same practices you need to apply to like build your AI system, you kind of need to apply to an AI judge as well. And so if you try to jump straight to phase 3, probably you're just going to have like a garbage automated scoring.
But you get some scores.
Lead you astray. Yeah, and people love to see that. You can make a pretty dashboard around it, and people are like, oh my God, amazing. And so you got to be cautious about that. And so I often see people jump there, and then, they maybe do some iteration with that, and then rubber hits the road when you put it in front of users, and they're like, wow, this sucks. And then you have to face the reality of like, hey, why doesn't this work? And then I see people kind of like backtrack. That's usually the most common that I see. The other thing is, just as I was talking about, the reality is there's a lot of discovery that happens. Sometimes you're iterating through, maybe you get into phase 2, you're starting to build like a data set to kind of like have evals. That's the place where you're starting to want to prevent regressions. In fast manual iteration, the reality is like there's so much low hanging fruit that it's hard to go in a really wrong direction. And so you don't maybe care about like, regressions or anything. You're just moving fast. And so once you're in that phase 2, you might then discover, hey, actually, this data set we've been building, these customers maybe are not the customers we want to target. We want to target different customers. And maybe that invalidates that data set entirely for the use case. And so you might fall back to, phase 1.
And that will make you go back and sort of start again in a way, so that you get on the right track, or the track you wanted to be on. Whether a track is right or wrong, but if you were having users, it's probably not a bad thing. But the question is whether the users you were intending to serve. So, and we can come back to this later if we'd like to. But I think a really interesting thing that you and I also spoke about before was what it really takes to go from being a software engineer to building AI solutions. So you personally, you came from this background where you actually already in like university got interested and you learned about machine learning and so forth. Whereas some of us, like myself, went on a pure software sort of engineering journey. And what does it really take to scale up? Because it really feels like this is the time to be able to leverage AI in your sort of app feature stack.
Totally. Yeah. And I mean, I think more and more it's going to be hard to avoid interacting with AI at some level, like in pretty much any job. Like, the reality is, like, I think most people are using ChatGPT, even outside of like engineering roles,
Yeah.
And so figuring out how to work effectively with AI is definitely something I think a lot of roles are going to have to contend with, and what that means for their role. But as it relates to engineering specifically, while I was at LinkedIn, one thing we constantly ran into was there's so much AI stuff we want to build. We don't have enough AI engineers to do it. And so my manager at the time basically worked to create this AI Academy. And I was one of the co-creators and instructors, where the entire idea was, let's help train more product managers and engineers to understand AI and how to build it. And then there was an entire apprenticeship program, essentially, where engineers would kind of like work as an AI engineer, mentored by a more senior AI engineer. And then they were kind of like ready to just handle and build AI features themselves. And that way we could scale up. And the thing that I quickly realized was, it's not necessarily the case that you're going to do something like that and then suddenly you're now building the state of the art, LLM model. That's maybe a stretch too far. However, you can learn enough to be productive and do things. And I think there's a lot of common principles just with good engineering. And so if you start to like look at a lot of like the patterns that are evolving out of like building agents effectively, a lot of them just come back to good engineering practices. And so I think that's why engineers are often just 80% of the way there. The missing 20% just comes back to that high data dependence. And so the way you think about validating needs to change. So instead of like, broadly speaking, for a lot of use cases, trying to write some form of unit test for an agent, probably not going to be very high value. It's just going to be friction, because you don't have enough data. And so like, I think broadly, a lot of engineering, traditional engineering work hasn't really thought about that task of like, how do I build a data set and shape the feedback so that I can optimize the system? And so that's really the last 20%. Once you start teaching those kind of like base level skills, software engineer can be a great AI engineer.
So where do you think people could go to learn these skills today if they don't work in a company that has an AI academy inside of the company? Like how do you see people normally go on that journey of learning?
Yeah, so I think there's a lot of free content out there. So some of the people to kind of like pay attention to in the space, Jason Liu, Hamal Hussein, Shreya Shankar, Hugo Brown.
We will have to find these links and add them in the comment
I'll share
after.
And so, all of them publish a lot of free content that's super helpful to learn. If you or your company are willing to pay some money, all of those people also have really great courses on Maven. And so that is also a great place where you can kind of learn these skills.
And so there's, so you can get some free content that people have made available, but you can pay for courses and you can take those. Or if you're a company, you could maybe you can't start your own AI academy inside of your company, but you can sort of make one by paying for courses and resources that are available out in the world. And something that I think is interesting, because obviously you've done a bunch of consulting I guess consulting is the right word that you've done in your career. When should a company, what type of situations have companies brought someone like you in? And how does the company know whether it would be valuable for them or not to bring someone like where you've been brought into companies? Like, what has been, because I'm sure you've been in a situation where like, oh, this was a great time to be brought in. This was a great time for me to add value. Or sometimes people either had a conversation with someone and decided this is not going to work out, or you're like, I can't actually add value?
Yeah. So the things I look at, so as far as like the companies when I was consulting that I really enjoyed helping, one was I wanted companies that had a pretty strong engineering team,
Yeah.
but maybe didn't have people who had like specific AI experience. Because this was a perfect opportunity to help them upskill the resources they had so that they
Yeah.
could be self-productive for, that phase they were in.
Yeah.
And I also looked for commitment from the management level that actually they wanted to fix this. The easy way to ensure that commitment is essentially for it to be a huge fire already. So if they had launched an AI product that users were complaining about on Twitter, that's a good sign, because that means that they're gonna pay attention to it and they're gonna care. The other is like if you give them a really big bill and they pay it up front, that's a sign that like, hey, they're committed and invested. And so really trying to find a place where that company is actually committed to solving the problem. I think there's a lot of companies who want to LARP it, or they say like, yes, this is a big problem because they have to say it's a big problem.
Yeah.
But when it comes down to like actual follow through and action and prioritizing, sometimes that's not there. I think a lot of like early consultants fall into that trap of like, oh, this is a great opportunity for me to, help this company. And then on the other side, they're not really committed. And if they're not committed, your ability to be successful is really low.
Yeah. So, and then it's probably not so fun or rewarding.
So, and I would say like most of the companies that came to me, I would say most of them got to a point where they launched to users or they did internal tests and it just wasn't working as good as it needed to. And they very often tried to jump to that phase 3 and then found out, hey, this isn't as easy as we thought it was. And that's usually like the ideal time for me to kind of like jump in.
That's not too late. That's what you're saying. That's not too late to ask for help. You're not like...
It's never too late.
Never too late to ask for help. But
as long as you have funds in your bank account.
Never too late to ask for help. But yeah, there's sometimes like you wonder, have I like gone so far that all the work I've done up until this point was waste, right? Like, is it too late to ask for? As in, it's probably not too late to ask for help, but there are probably ideal spots to ask for help. Where maybe if you barely know even what you want to build, it's probably not also a great idea to ask for help because you're just floating around not without direction, and then you don't have that buy-in. As you said, you kind of want to have that support.
Yeah. So I'd say the sweet spot is probably like you have like a decent validated idea of like the thing you're building. And then you haven't got so far into building sort of like eval infrastructure around that it's hard to unwind out of. Because if you've like started that journey and you've gone too hard into it, and if you didn't really know what you were doing and you made some like critical mistakes early on, those might be hard to undo.
And then you kind of have to start clean again. And throughout your experience, because you have the unusual amount of time being like ML, data science, AI for about a decade. Throughout this time, you obviously mentioned the white space that caused issues, but what are some unexpected challenges in building AI-powered solutions? Like, what is something you were like, never thought that was going to cause a problem, or maybe it wasn't technology was a problem, maybe it was people, who knows?
People are always a challenge, I would say, but yeah. So I think some of the biggest things that come to mind. One is hardware. So a lot of people have like run into the experience of like there's a lot of companies, especially scaled companies, that for a period of time had deployments across mixed hardware. And I think for a long time, I never thought about that causing issues. But if you have, these deep models that are like running on these optimized kernels, like the hardware actually matters. And
interesting.
Working on different hardware sometimes means, oh, actually, I get different outputs. And so
I
that
wouldn't
means
have
that
known.
just on the basis of running this on a different GPU, you might get a different
Ah,
result because, and really just comes down to like, there's like bugs, either in
mm,
the hardware or the CUDA kernel,
mm.
Um,
Ah,
and those can be tricky to track down because, really it comes down to like, what host is this running on,
yeah.
And so
I
that's like
would
one
have
of the trickiest, I
never.
said.
I would have never even thought about that
And most people
because
don't until it bites you.
that is a really interesting challenge of, yeah, having either at least having the same hardware for the same models and the same, because then you get predictable results. Because I
Mhm.
also think that there's this push to try and make the most out of the hardware you already own so that you don't go and just buy a bunch of new hardware, spending loads of money. So there's a weird balance there, maybe, of trying
Yeah.
to make sure that
And it gets a
maintain
lot more
quality.
complicated too.
Yeah.
So some folks might remember a lot of people complaining about Anthropic model quality degrading
Yeah.
suddenly. And when you look into the report they released on what happened, there was basically just a bunch of like infrastructure flags and things just kind of like compounded against each other to
Wow.
mean that, oh, the output was not what it was supposed to be.
So infrastructure matters, which is
Yep.
rather fascinating because it's, well, this was really interesting. I love it. And but where are you seeing, if you were to look at into the future, we are, here at the beginning of 2026, obviously a lot changed quite rapidly over time here. And even the last year, I feel agents got so much better with tool calling and how to manage the context for agents as well. Like also we saw context windows exploding, but sometimes I'm not sure whether huge context is always good, but that's a different conversation. Where do you see things going and what are you excited about that is sort of on the horizon?
Yeah. So I think the thing that I'm most excited about, the reality is I think there's been a lot of experimentation on like how do you make agents useful and like what are the different infrastructure components that
Yeah,
exist there. So we had experiments with MCP, we have
yeah.
sub commands, sub agents, and I think we're starting to get to a place to where we're starting to understand better ways to do this.
Mm.
And so what I think is really missing in like building effective agents is like good modularity. So
Okay.
when I look at MCP, the thing I don't like about it is it's not clear how exactly to modularize this. Meaning,
Okay.
I want to build, you have like some base level of
Mm.
capabilities you build out in the MCP. These are like tools, and then I want to build workflows on top of that, and then I want to build
Yeah.
workflows on top of that, et cetera, et cetera.
Yeah.
And this kind of modularity and extensibility is like what makes software great. And so I want
Yeah.
to see those same benefits come to like how we build agents. And I think we're
Mm.
starting to get there by figuring out the right patterns. And I think that's going to unlock a lot because I feel like there's a lot of places where, hey, I would like to use this thing in my setup.
Mm.
And I can't quite do it because the modularity is not there. I can't change it
Yeah.
in the way that I need to fit the peculiarities of my setup. And
Yeah.
I think once we kind of like have that right abstraction there, I think that that's going to make things
Mm.
work. We're going to see like a lot of like building on top of each other, and I
Yeah.
think that you're going to see things kind of like explode. I think obviously tool calling is going to continue to get better. That's great.
Yeah.
Inference costs are going to continue to go down at least for a little bit, so that's
Yeah.
going to be great. So I really think we're starting to get to a point to where people can start to have AI do a lot more for them. So for those of you who aren't familiar, there's this great project called Claudebot, uh,
Mm.
which is basically an AI personal assistant.
Well,
Uh,
I don't know about Claude Bot.
yes,
Tell us more.
so this is an independent developer started this. It's an open source project that's just
Mm.
taken off by storm. And basically, it has a lot of capabilities to connect to a lot of different messaging platforms. It has like a whole
Mm.
architecture that supports skills, so you can teach the AI new things.
Yeah.
It has memory integration, so it remembers things about you. And so I now have a personal assistant running my life in a lot of ways. And
That's
just as
awesome.
some examples of what it did. I'm planning a ski trip with my best friend. It went and reviewed a bunch of Airbnbs and found one to book. It booked ski lessons for my fiance and me.
Wow.
It booked an entire Valentine's Day weekend, ordered flowers, booked restaurant reservations, and emailed the hotel to let them know our puppy was coming with us.
Oh.
And so, the future is kind of here.
Yeah.
It's expensive, but it's here.
I like that. The future is here, but it's expensive. And I feel that there is a lot of money that you can get a lot of interesting things for money, but also inference. So it was interesting that you said inference costs are going to continue to go down. What is driving that cost to go down, and what will stop it from continue to go down?
Yeah. So as far as continuing to go down, there's just a lot of investment in data centers and making inference as optimal as possible in specific hardware to power this. And so, like, it seems pretty clear that inference costs are going to continue to go down. Whether or not that's going to be completely offset just by having larger models, who knows? But it seems pretty clear that the cost per flop is going to kind of drop still. As far as what's going to stop it, this kind of like starts to extend outside of my expertise. But I tend to find that there's a researcher, Tim Detmers, that wrote a great blog post that resonates with sort of like how I feel about the situation, which is basically that, like, at the end of the day, the current software piece that we're using of like transformers is like close to optimal for the hardware we have today. And we're running out of space on the chips. Meaning, like, it seems like at the end of the day, physics is a hard constraint. And so, it seems unlikely that there's anything that's going to change that. Maybe quantum computing somehow
how's that
pops
gonna
off in a way. But
what can it do for us? Yeah, it's an interesting question.
So
well, okay, so I think there's some really interesting things, by the way, that I know we talked for quite a while now, but there's a few things that really stood out for me. I've actually took notes. What was really cool was obviously being able to learn, like the jump, being able to learn, like if you are a good software engineer or don't feel like you're behind, you actually have a good foundation to stand on, and there's both free resources and paid resources that you can use to learn. And then you spoke about this modularity, and funnily for me, that feels like those traditional software skills and modularity, maybe by bringing more traditional software engineers into this space, maybe we will actually also be able to have more people behind sort of the engineering power to get to modularity. I think we all like a bit of composability and modularity, and as you said, building on top of things. And I think it's interesting because when I first started getting my head a little bit around sub-agents, I'm like, are we back to just microservices? Like, is this just us breaking things apart into specialized, pieces of software? Obviously a bit different, but that also means that we will need all of the same infrastructure and pieces that we've needed to run before. How would you actually describe a sub-agent? Is it a specialized agent, really? Or would you describe it differently?
The challenge in describing it is what it means changes depending on the harness you're using. And so, it means one thing in one harness, and it can mean another thing in another harness. So to speak from Claude Code,
that is a good insight, by the way, just in general, that this may not be a universal truth.
Yeah. And, back to the comment I made about evals being a bad load-bearing term, I would say almost every term in the space right now is a bad load-bearing term. because there's just so much noise around everything that very rarely are people talking about the exact same thing when they use a word. That's maybe a little bit of general life advice for everybody too. It's just like,
I think so.
When you disagree with somebody, and there's a certain word being used, make sure you mean the same thing with that word.
Yeah, no, I hear you. I feel like the same probably still exists with, when people say API. What do they really mean? Do they talk like, what are they talking about when they say
sometimes people really explicitly mean a REST API. Sometimes people really explicitly mean like something that communicates over HTTPS protocol, and it's like, there's a lot of like assumptions packaged up in it, and those assumptions vary across people sometimes.
Yeah, and some people refer to, the library they pull into their, build as an. I mean, it is interacting with an API of another service, and they have a API, but API is such a. And sometimes people simply talk about the interface, but not about the instances of running it. But this is a sidetrack. But yeah, general life advice. Check that you are actually talking about the same thing. Just because you use the same word doesn't mean you're talking about the same thing. But as we wrap up, could you just give an example of subagents in one context so that we share a bit about that?
Yeah, so one place I tend to use subagents from Claude Code is I have a lot of subagents defined to do different types of code review. And so I'm a big fan of this series of talks from someone at Adobe, Sean Parent. And he has these talks called Better Code. And it talks about like simple practices to like write better code. It's from a C++ perspective, but I find that the advice is generally good advice for making more readable, more maintainable code. And so I have a subagent that kind of like has all of those practices kind of defined and how the agent should review it. So like subagent is really just a prompt for starters. Okay. And so this is just a prepackaged prompt I have to kind of instruct the AI to do something. And the key thing that I think is different from like just being a prompt is usually when someone says subagent, usually it implies that the context is separate from the main agent that spawns it. And the reason that can be important is, especially when you want to start running things for longer periods of time more autonomously, as you start to use up your context, the model gets dumber, basically, because it starts getting confused because there's just too much going on. And, a lot of people get frustrated, but we should remember humans are the same way. When you got too much going on in your head, you're also less effective. Yeah. And so, Dex Horathy from the company Human Eval has this threshold, I think, of 50 or 60% context usage is kind of like, that's when it gets dumb. And so you should do something clear context. And so if you have something like a code review, I don't care about a lot of the intermediary output. I just want to know what's the final result. And so subagent is a great tool there because this subagent can go off and do whatever it wants without polluting my main context and then just give me the end result.
Yeah. So it basically keeps things sane and functional for longer versus having. But yeah, I do totally feel that with the context window and even the parts where you try to summarize context to sort of start again or say like sometimes that doesn't even have a great effect either because you may lose critical details. And I will learn too how to figure this out, but I think that's tricky. So finally, as we've wrapped this up, what is your advice to builders? What is? I mean, we talked about many things throughout today, but as a leaving piece, as I bring up some links to your personal websites, share some advice.
Yeah, so I think the biggest advice is it can feel disorienting how fast the field moves, and it's easy to feel like you're perpetually behind. And I think the best antidote to this is really to keep trying things, keep experimenting, and try not to take on too much too quick. So, I see like with that sort of maturity model I talked about, I see people trying to jump to the end stages of it before they've really even tried to experiment with the early stages with it. Similar thing with coding agents. People often try to jump to like these complex multi-agent setups before they've even gotten one agent to work. And so my biggest thing is, everything can feel overwhelming and daunting. And the antidote to that is to downsize it. What is the small tangible thing that I can do that takes a step forward? Do that thing and then find the next one and just keep going.
Yeah, because by the way, I definitely feel the part where I feel like I'm constantly behind. So no, constantly feeling the things are moving, feeling a bit behind for sure. Here is the link to your website that is in the YouTube comments. Can add them later to LinkedIn comments as well, but you can find Skylar on his website. But you can also find Skylar on LinkedIn. It's a bit longer, but it's not a difficult Skylar Payne. It's not that hard to add that at the end of the LinkedIn link. And as I said, you can find the links on YouTube. And you're also on X. What do you post about on X? Why should people follow you on X?
I mostly rant about observability platforms these days, but I just post little musings about coding agents and doing AI well. So,
well, thank you, Skylar. And if anyone wants to get started with inference and building some agents, you can obviously check out also router.tetra.ai, which is a router that helps you route to both inference and tools, which you can sign up to. And if you sign up with a business email, you get $5 free. And if you sign up via Goose, for those who know what Goose is, I can share that link later. You can get some more credits. So feel free to check that out. My name is Erica Hughberg, and I work at TechRate. Hence, this is a opportunity for me to share what we are doing there. And and if you are so inclined, I am hosting my first ever build-a-thon, which I didn't even plan to mention here today. But since I realized I was talking about TechRate, I might as well mention it. So this is a build-a-thon that is especially maybe useful if you are starting out building AI features in your app or wanting to build a completely new app that has AI features in it. I am hosting a build-a-thon February 16th to 17th, but you need to apply before the 5th of February, and I'm there to help you be successful in building some AI features, and more people will be there as well to help support you. But if you want to block some time to do that, that's where you can hang out with me and do more building. But yeah, thank you, Skylar, and thank you for bearing with me there as I went through my unprepared little pitch for my build-a-thon that I'm hosting. So thank you so much, Skylar, and anyone who's been listening in, please connect with Skylar and follow him on X and connect with him on LinkedIn. And thank you so much. It was lovely.
Awesome. Thank you.
Thank you.